So today, we are going to be talking about our third center. So we've talked about the circumcenter, which is where the segment bisectors of the triangle intersect. We talked about the centroid, which is found where the medians of a triangle intersect, and the medians connect a midpoint to its opposite vertex. And now we're going to talk about our third center today. Let me see if I can zoom this in just a little bit here so you can get some notes. So the third center we're going to talk about today is the orthocenter. Orthocenter. And in parentheses after that, I want you to put in H. In H. Okay, now, the orthocenter of a triangle is where the altitudes of a triangle intersect. So another new line name in a triangle, an altitude. All right, so what is an altitude? An altitude connects a vertex of a triangle to its opposite side at 90 degrees. So these are your height lines. Like this is what we would need to find the area of a triangle. We would need a line that connects to its opposite side at 90 degrees. Now medians go from the midpoint back to the corners, but you'll notice if you look at your median papers, those don't connect at 90 degrees. Now we're going to start and we're going to connect our points back at 90 degrees. Now I want to draw your attention to a lesson that we previously did. Let me just kind of bring it up here on the screen. Hang on. See if I can. That. So you should recall this lesson that we just did, constructing perpendicular segments, right? And we did a couple different things. Like, for example, in this question number 3 here, right, what we did was we took and we had this original line segment here, and there was a point that was not in the middle of that line segment. And what we did was we created that point as the center of a new circle. And then once we knew that that point was equidistant from both endpoints of that new circle, it then had to sit on the perpendicular bisector line. And so then we were able to do our crossing marks and drop a perpendicular line through that point, even though that's not the center of the original line segment. That was one skill that we did. And then the other skill was like up here in number 2, where we had an original line segment, and then we had some point floating out here in space. And we had to draw a perpendicular line from that point back to another segment, okay? And so what we did was we made this the center of a circle by setting our compass to some random, and it didn't matter what length we set our compass to, as long as whatever that distance was here, it was equidistant here, because again, those are both radiuses I just drew up there, right? And if this point is equidistant from the endpoints of a line segment, it must sit on the perpendicular bisector line. That was that perpendicular bisector theorem, right? So what we talked about was then we would just ignore that part of the line and then this little part over here. And what we would try to do is find the midpoint of this new line segment that stretched between those arcs, okay? Now, I want you to think about something. This is a 90-degree angle right here. If I were to actually draw a triangle here, we just had an altitude line right there. You see that? It connects a corner back to a side of a triangle at 90 degrees. So that's exactly what we're going to do with today's lesson, right? I want you to think about this for just a second. Again, if I were to kind of cover up parts of this triangle here, like what if I were to cover up this part of the triangle and maybe this part of the triangle here, and let's pretend, now look, see, there's the lesson we just did. There's a point floating out here in space, and we want to connect it back to this line segment at 90 degrees. See what I'm doing? It's the same thing, right? So then all I need to do is make that point, which happens to be the vertex of the triangle now, okay? We have to make that the center of a circle, so then I can open my compass up and I can mark down here and I can mark over here. Now, the problem is that we don't have a whole lot of line to work with. So with this particular type of center, I'm going to tell you that the suggestion is that you just start by extending all of the sides of your triangle. So let's do that. So we're going to take our triangle here. I'm just going to take my ruler and I'm going to get it right up along the side here. And you want to make sure that when you're doing this, your pencil like runs right along where the original line is, so that when you do finally extend it out, it's pretty close to where the original line is. Let's see if I can get that. So like That's pretty close. So see how I extended my line of my side of my triangle there to work with? Now you're going to have to keep track of these extended lines and how they relate to the side of the triangle, right? So this line that we just extended right there is actually this side of the triangle. We're going to do the same thing on the other sides too. So I'm going to take this side and we're going to extend out our line this way. So I'm going to extend out that segment, side of the triangle. I'm going to come over here and I'm going to do the same thing over here. So that I have nice long line segments to work with, okay? Okay, so let's do the altitude line from this vertex right here. So again, the altitude is going to go from this point back to this side of the triangle at 90 degrees. That's the goal, okay? So what we'll do is we'll take our compass, and I'm going to kind of turn my paper here because it's easier for me to work size. I'm going to put my compass pointer at the point where I want it. And again, I'm going to open up my compass, and it's going to have to be big enough that I can get back to the side of my triangle with clear intersection. So you want to kind of test it out before you draw it, right? So I can see that I can cross here, and I can come out here, and I can cross out here. And you can see why I had to extend that line now, okay? So I'm going to do that. I'm going to make a crossing arc down here like that. And I'm going to make a crossing arc over here like that. Now, do you see it? This is the same construction that I just showed you a second ago. Look, there's the radius of the circle. There's the radius of the circle, which means that this point, this vertex right here, sits on the perpendicular bisector of that new segment that we created that stretches between those intersections right there, okay? So then all we have to do is perpendicular bisect this new segment here. So once we have our crossing arcs, we can come over here. We set our compass point here. Now you want to try to be, as close on these arcs as possible with your compass pointer. And then you're going to kind of ballpark where you think your 90-degree line is going to go. I think mine's going to kind of come in this range down here. And I'm going to come over to the other side and get my pointer set, get my crossing arc down there. See what I did? So I went more than halfway. And I did more than halfway, keeping that same distance, right? Again, I'm doing the same construction, the more than halfway. So to create the 90-degree bisector line, but what I'm bisecting is this segment here. Now, not the side of the triangle, this segment here. And then I'll take my straight edge and I'll put my pencil tip down and get my ruler where I want it and my pencil tip down.
Where did you make the arc at?
Well, I made these crossing arcs over here initially, and then I made these crossing arcs down here. Okay? And then I can draw my altitude line like that. And what should happen is that this point should now meet this line segment at 90 degrees. And that's where your protractor is going to come into play to verify that. So then you're going to come down here with your protractor, and you're going to check, and you can see that I have a nice straight 90-degree line right there. So I'm going to mark it 90 degrees. Okay? Let me come around and take a look and see how you're doing. Okay? If you think you've got it, then you can go ahead and do the other altitude lines, and I'm going to come around and check and just see how everybody's doing. Okay, so looking pretty good. I'm gonna do this one next, just in case you wanna, check. I'll give you this one in just a second. But you're gonna do 90-degree lines from all 3 points. Do not move on to the second question down here. We're not gonna do that one. We're gonna do a different one, okay? But you're gonna do both of those. So I'm gonna do this one, and then let's see how you do. All right. All right. I'll give you this one. So I told you I was gonna turn my paper to do this intersection. So this one should look like this, right? So I set my compass pointer here. I want to get back to this side of the triangle. You can see my arcs right here are what I made from putting my pointer up here. That's equidistant. That's equidistant. I perpendicular bisected that line, and I arced down here, and I got my 90-degree perpendicular bisector of that segment, which drops this 90-degree line to that side of the triangle, and then I can verify it with my protractor. I got 90 degrees. So then I'm going to mark it like that. Now, I already have an idea where my orthocenter should meet, but again, you still have to show me the construction for the orthocenter for all three altitudes. This just serves as a checkpoint, but your third altitude, which is going to go from this corner back to this side of the triangle at 90 degrees, should go right through that point right there, because the orthocenter is where the three altitudes of the triangle intersect. All right, so I'm going to go ahead and do this corner now like this. So I would turn my paper like this, set my pointer, arc, arc, perpendicular, bisect. Let's see if you can get it finished. Go ahead. So are we on the next triangle? Okay, this is what you should have come up with for your last one here, right? So again, I put my compass pointer up here. This time I was able to get both sides of my triangle within the triangle. And then I perpendicular bisected that line segment, crossed down here, dropped my 90-degree line, and there is my orthocenter. So now I'm going to straighten my paper back up here again. Okay. Okay. Okay, let's take some notes here. Okay, ready to focus?
Yes, sir.
Here we go. Let's take some notes. Some important things to jot down. Number one, we're going to label our orthocenter with an H. Okay? So when you're constructing an orthocenter, I'm going to see these 90-degree altitude lines. I'm going to see an H for your orthocenter like that. All right? Now, let's label the vertices of our triangle. So we can use anything other than U, H, S, or N. Those are our off-limits letters, right? We've already seen the U, the S. Now we have the H. All right? So I'm just going to do something like A, B, C. Simple like that. All right. This is really important vocabulary. You ready? Okay. I want you to label the feet of the altitudes. Okay. The feet of the altitudes, or singular, a foot of an altitude, is where the altitude line meets the side of the triangle at 90 degrees. So make a note that this point right here is called a foot. That's the foot of the altitude. So if I called this D, D would be the foot of altitude AH. Did you catch that? D is the foot of altitude AH. So in that case, then E would be the foot of altitude what? HB, that'll work, sure. Of altitude HB. E would be the foot of altitude HB. And then I could say F would be what? It would be on altitude CH, good. But what is F called? A foot. The foot of altitude CH. 3 altitudes, 3 feet. Okay? Important you understand the foot language. Yes, ma'am. See through where? Like this one here? Okay, so my compass pointer was here. Okay, I opened it to create that arc and that one over there. So I put my compass pointer up here and I made this arc out here and this arc out here, right? Because I'm making point C equidistant from its opposite side of the triangle. And then from each of those points, I went more than halfway and I arced here, down here, and then from over here, I arced down there like that. Okay? Okay, last thing we're going to do is we're going to color our altitude lines one color. So all 3 lines, one color. So I'm going to use kind of a pinkish color for my altitude lines. So altitude line. Altitude line. Altitude line. Pink is dying out already. All right, and so that's how you indicate your ortho center. That's how you'll construct it and show me the difference. Circumcenter, where the segment bisectors meet. Centroid, where the medians meet. Orthocenter, where the altitudes meet. 3 centers of a triangle. Good?
So we're going to be able to do all of this in one triangle.
Today.
What?
But before we do that, let's just do one more orthocenter on the back side. We're going to do the problem on the top here. That second question, you could try it if you want later, if you just need a little extra practice. It's a little challenging because the orthocenter is pretty far away off the triangle, but you can do it. It's not impossible. Okay? All right, but let's do this one. This one's a fairly easy orthocenter produce. So I'm going to let you do this one all on your own, and then we'll take a look at the answer, and then we'll move on to what we're going to do for your project. All right, here we go. Go for it. All right, here's what you should have come up with here. Yeah. Okay, now listen. Hang on. Let me have everybody focus. Listen up. Okay? Shh. Right? So one thing that I want to make sure to point out to you. Putting this marking on an angle that's not 90 degrees is not going to help you with your project. Because you're not going to be able to do your project if you don't actually create a 90-degree angle. So it's not about you putting something on your paper to try to trick me and say, hey, look, Mr. Farkas, I got a 90-degree angle when it's obviously an obtuse angle. That isn't going to do anything for you, because what's going to end up happening is when you have to use these points that you're creating in your project to do something else. And if your points are off, if your orthocenter, circumcenter, or centroid are off, then your whole project is going to be off. So the point of having you check this is not for you to go, hey, look, I put the right markings on my thing and now I can trick Mr. Farkas. That's not the point. The point is for you to check that so that you don't get further into your project and then go, hey, how come this isn't working? It's not working because you didn't actually have a 90-degree angle here. So verify your 90-degree angles, because if you don't have a 90-degree angle, your circumcenter or your orthocenter is going to be in the wrong place. And if your orthocenter is in the wrong place, the rest of your project is going to fall apart, because everything has to be in exactly the right place for your project to work. Okay? So you've got to practice checking things like the circumcenter. You don't need to construct the circumcircle every time, but what you do need to do to check and see if you're right is you need to make sure that that point is equidistant from all 3 vertices. If it's not, you did something wrong, stop and redo it before you move on. Because if you move on and it's in the wrong place, your whole project's going to be wrong. Okay? It's important that you do that. It's like messing up a number at the very top of an algebra problem. You can't get it right if you write the wrong number down. If it's 15 and you write 5, it's going to be wrong. Same thing with the centroid, right? You should be able to measure the short one and then mark off 2 of them on the long one. Not because I'm asking you to do it, but because it helps you make sure that you had it in the right place. And with this one, you're verifying the 90 degrees, not because I'm telling you to do it, but because you want to make sure that you have it in the right place so that when you do your project, it's going to work out okay. Okay, well, hopefully you follow those instructions. All right, so I'm going to pass out the next paper to you. Don't start doing anything just yet, all right? So you can see the instructions. You can see here it says, construct the circumcenter, the centroid, and the orthocenter, all on the one given triangle below. Okay? You're going to label only the centers. That's the only labels I want you to put. Did you hear that? Only the centers. So you should only have a U, an H, and an S for labels on your triangle. Each set of 3 lines, the segment bisectors, the medians, and the altitudes, should be a separate color. you should have 3 separate colors on your triangle. Okay? Now, if you take it one step at a time, it's really not that bad. Okay? It can look confusing in the end, but if you take it one step at a time, it's not that bad. All right? So let's start with this. Let's start by constructing the circumcenter. Okay? So go ahead and start working on building your circumcenter, and let's see how you do. Okay, little spoiler alert. I'll put it up on the screen what it should look like when you're done with your circumcenter, okay? Well, you don't have to look up. You just do your circumcenter, but I'm going to put it up there just so for those who have a goal to look at and then aren't too confused. Okay, if you don't want to look up, don't look up. If you do want to look up, this is what it should look like when you're done. So here's a little spoiler alert. Your triangle will now start to look like this. Here's what your triangle should look like when you add in the orthocenter. So again, this is kind of the zoomed in version of the first triangle. So what I'm going to do is, on the video after you guys leave class, I will put right after this a picture of the second triangle completed. So you can come to the end of the video and you can take a look at the answer for the triangle that's on the back of your paper. And you can see what that one looks like. And then that way you have that answer to work with as you're studying and getting ready for Thursday. Again, remember, or Friday. When I see you on Friday, I'm going to expect you to come in and be able to knock out 2 triangles with 3 centers on them. Boom, boom, boom. So that we can have this down. So you've got to be good at finding these skills. The better you get at this, the easier your project's going to be. All right? So the answer for the second one will come up on the video in just a second. Okay, so here's the second triangle right here. You can see, like, here's the actual original triangle right there, hiding in there, right? We got a lot of lines on here, right? And so, of course, we have our orthocenter out here where our segment bisectors meet. And we have our centroid in here where our medians meet. And then we have our orthocenter. Did I say orthocenter up here? This is your circumcenter, centroid, and orthocenter, right? That's the correct language. Okay. And then you can see where the altitudes meet, and they do meet outside the triangle, right? Like you can see, like, just take this altitude line for a second, right? Even though our triangle's out here, we've seen questions like that before where it's like dash, 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 find the area of the triangle. And there's that 90-degree marker out here outside of the triangle. You've seen stuff like that before. So this is just a construction of what that would look like. Okay. So when I see you next, then we're going to be doing this and want you to be able to do it efficiently. Okay, bye.